Welcome to the DIY Honda Garage channel. Welcome to our presentation on diagnosing DTC B1175, which indicates a malfunction in the fuel level sensor, also known as the fuel gauge sending unit. In the 2006 to 2011 Honda Civic, the fuel level sensor is crucial for measuring the amount of fuel in the tank, ensuring accurate readings on the dashboard fuel gauge. This sensor is located in the fuel tank and transmits data to the gauge control module, typically mounted on the instrument panel cluster. When there is a malfunction, drivers may experience incorrect fuel level readings. The diagnostic trouble code DTC will trigger, prompting the need for a thorough examination. Let's explore the details of this error code in further slides. DTC B1175 represents a malfunction in the fuel level sensor circuit, responsible for sending accurate fuel level information from the tank to the gauge control module. The fuel level sensor, located within the fuel tank, measures the current quantity of fuel. It communicates with the gauge control module, which displays the information on the fuel gauge visible to the driver. If this sensor fails, it can lead to incorrect readings, causing inconvenience and the risk of running out of fuel unexpectedly. Diagnosing this error requires understanding the wiring and connections between the fuel tank unit and the gauge control module, essential for pinpointing the issue. There are several potential causes for DTC B1175. First, a malfunction in the fuel level sensor itself is a common reason. The sensor could be damaged or worn, leading to inaccurate readings. Secondly, wiring issues, such as open circuits or high resistance in the wires connecting the sensor to the gauge control module, could cause the DTC to trigger. Thirdly, connector problems like corrosion or poor connections can interrupt the data flow and result in malfunction. Each of these factors can compromise the reliability of the fuel gauge and necessitate inspection during the diagnostic process. The symptoms associated with DTC B1175 primarily revolve around erratic or inaccurate fuel gauge readings. Drivers may notice that the fuel gauge fluctuates unexpectedly or remains at an incorrect level, suggesting either an overestimation or underestimation of fuel quantity. In some cases, the fuel gauge may fail to operate altogether, showing empty regardless of the actual fuel level. This can lead to dashboard warning lights illuminating, signaling an issue with the vehicle's fuel monitoring system. These symptoms can be frustrating and may lead to unexpected fuel shortages if not addressed promptly. The first step in troubleshooting DTC B1175 involves clearing the diagnostic trouble codes using the HDS, which stands for Honda Diagnostic System. After clearing the codes, turn the ignition switch to the lock position and then back to the on position, also referred to as I. This step is crucial because it resets the vehicle's systems. After this, it's important to wait for approximately 30 seconds to allow systems to stabilize. These actions serve to prepare the vehicle diagnostic system for checking if the fault persists, laying the groundwork for further investigation based on results. In this step, after performing the initial reset, use the HDS once again to check for any present DTCs. It is vital to carefully record the results obtained, particularly if DTC B1175 is indicated again. If B1175 is present, it suggests that the issue has not been resolved, and you should proceed to the next steps in troubleshooting. Conversely, if the DTC is not indicated, it suggests that the issue may be intermittent. In that case, further examination of the fuel level sensor circuit for loose or poor connections is advised. In this third troubleshooting step, start by turning the ignition switch to the lock position. Next, disconnect the fuel tank unit 4P connector and the gauge control module's 36P connector. By performing these actions, you prepare the system for the continuity test. which is vital for further investigating the connection between these two critical components. It is essential to ensure that each connector is removed correctly to avoid any damage. Once disconnection is achieved, proceed to check for continuity between the connectors to determine wiring integrity. This step requires checking for continuity between the terminals of the connector for the gauge control module and the fuel tank unit. Specifically, examine terminals number 32 and number 33 of the 36P connector, and terminals number 1 and number 3 of the 4P connector. This continuity test will reveal whether there is an uninterrupted path for the electrical signal. If continuity exists, it indicates that the wiring is intact, allowing you to proceed to the next steps of testing the fuel gauge sending unit. However, if there is no continuity, it suggests an issue like an open circuit or high resistance, indicating the need for repairs in the wiring between the two units. At this stage, conduct a test of the fuel gauge sending unit using the appropriate method for your engine type, whether it is the R18A1 or K20Z3 engine. This test is critical as it will determine whether the sending unit itself is functioning correctly. If the test indicates that the fuel gauge sending unit is operating within specifications, this suggests that the issue resides elsewhere, specifically within the gauge control module. Conversely, if the sending unit fails the test, it indicates the need for replacement of the fuel tank unit, which could be the root cause of the malfunction. After completing the necessary repairs or replacements, it is vital to conduct a final verification of the repairs made. This involves checking all electrical connections to ensure that they are secure and properly insulated. Once you have reassembled the vehicle components, initiate a test of the fuel gauge operation to confirm that the issue has been resolved. It's crucial to ensure that the fuel gauge reflects accurate readings and no warning lights remain illuminated on the dashboard. This verification step will help confirm the effectiveness of the interventions taken during the troubleshooting process. Preventive maintenance is essential to avoid recurrence of DTC B1175. Regular inspections of the wiring and connectors associated with the fuel level sensor will aid in early detection of potential issues such as frays or corrosion. It is advisable for vehicle owners to monitor the fuel gauge performance continually, paying attention to any erratic behavior. Performing these routine checks can save time and costs associated with extensive repairs down the line. Additionally, addressing minor issues before they escalate is a smart approach to vehicle maintenance, ensuring lasting performance of the fuel gauge system. In conclusion, understanding the components and their roles in the fuel gauge system is key to effectively diagnosing DTC B1175. It is essential to follow the structured troubleshooting steps meticulously to pinpoint the issues accurately. This systematic approach not only ensures that the vehicle operates smoothly, but also helps in extending the life of the fuel monitoring system. From verifying connections to testing components, attention to detail is paramount. Ultimately, ensuring that the fuel gauge system functions properly serves to enhance the overall safety and reliability of the Honda Civic. Please like and subscribe to the channel. See you next time.